Hello students. Today we will discuss about uh, the second major point to be considered by a computer architect, that is called as the IC related, that is the major integrated circuit uh, related technology aspect, that is the various trends in technology. So in the previous session we were discussing about various instruction set architectures. So similarly, another important points to be discussed on the various designer aspect, means from the point of a designer, is about the technological aspect also. That is why we are discussing about the various trends in technology. So as I have mentioned, who is an architect or a designer, he must plan for a technology, he must plan for technology changes that can increase the lifetime of a successful computer. So every time when he tries to design a new computer system, he should adopt the technologies, means adopt the changes that is happening with the day-to-day life. So he need to consider the current development, and accordingly the technology improvement must be always added to the new version or the new system that is to be created. So while he is looking into these technology aspects, 5 implementation technologies must be considered. The major technologies that is normally being considered by various architects are given below. The first point is the IC logic technology, integrated circuit logic technology, the development of integrated circuits. So that is why we are having the earlier a full room placed computer. A computer was placed within a single room itself. It takes the entire room for placing that computer, is being converted into a machine that can be held by our hand itself. Nowadays we can use that machine either within our lap or by using our hand itself. So the device became very smaller. It is only because of the development of the integrated circuit logic technology or the IC technology. So the combined effect is growth rate in transistor count on a chip. So what is the major element present in a chip? The major element present in a chip is transistor, and we had a very good growth rate in the number of transistors present in the chip. So if we increase the number of transistors, automatically the capability of that IC chip will also be increased. So what is happening in the IC logic technology is that there is a huge growth rate in the number of transistors present in an IC chip. So what is that growth rate? You can see there was about 40% to 55% growth per year in the number of transistors present in a particular chip. That means it was actually doubling. The number of transistors present in an IC was doubling in every 18 to 24 months. So a scientist called as Moore have defined a law stating that the number of transistors must be doubled, or that must be increased in a rapid or in a good percentage in every year. So that what is that actually means? If we can increase the number of transistors, automatically we can improve the capability of an IC chip. So if you try to increase the number of transistors every year, when we try to develop a new IC, new processor, automatically the capability will also be improved. So that based on that, so that is one of the major technology. That is the first point we are mentioning is about the integrated circuit logic technology only, because that is the major point where we are actually getting an IC processor chip which is of very small size with more number of transistors. One more point to be discussed is when we actually increase the number of transistors, automatically what actually happens is it reduces the size of the IC also. So more transistors, so assume if we are having a bag and if we are trying to add more books into that bag, automatically the size up to some level only we can fill that bag. But if we increase the number of transistors, we can actually reduce the size. So transistor size became very smaller so that we can decrease the size of the entire integrated circuit chip itself. So more transistors, so every year it is being doubled. So if we are using 1 million transistors this year, next time it is doubling, means they will be using 2 million transistors within a chip. But in the meantime we can see that we are actually reducing the size of the chip also. So this is what is happening, that is, if we increase the number of transistors, it will increase the capability of IC. It will also decrease the size of integrated circuit chip also. That is actually happening in the IC technology for PC or similar device development. Now second point to be considered is the semiconductor dynamic random access memory, which is called as DRAM. So which is actually the main technology behind the primary memory or the main memory of a computer system. That you can imagine, so if I am buying a laptop or a mobile phone today with a RAM capacity of 4 GB, next time surely will be buying a mobile phone with more primary memory capacity. For example, I will be trying to buy a system with 8 GB primary memory capability. So the primary memory capacity, so what is happening in the technology, the capacity per DRAM chip has increased by about 25% to 40% per year recently. So capacity, so every time they are actually increasing the capacity of primary memory. So this DRAM technology is the foundation of main memory, which is the most important memory present in a computer system. Similarly, another technology point to be discussed is the semiconductor flash memory. Semiconductor flash memory, which is used as the internal memory of our system, or which can also be used as an external memory. For example, we are using USB pen drive, which is an example for a flash memory, or our mobile phones nowadays consist of internal memory. Without adding any external memory card, we are having a memory, that is internal memory available, which is actually used as a secondary memory in our system, which is also made of semiconductor device, which is called as semiconductor flash. It is a non-volatile semiconductor memory, means dynamic RAM is volatile. Once the power is off, the memory content will be removed. But in the case of flash memory, it is non-volatile. Even if the power goes, the content will be retained within the device. So which is the internal storage device used in the mobile phone devices, which is a major technology used for any of the computer system design. Then comes another category of memory, which is called as magnetic disk technology, disk like CD. That is another memory usage which is usually used for huge storage, because we cannot use flash memory or dynamic RAM memory for huge data storage, because the capacity is less for those two. But we cannot have more capacity, because if the capacity is being increased, the cost will also be increased. So if we simply want to store some huge amount of data, we cannot use those memory. So we are using CD like memories, which cost very less, and we can have more memory spaces where we can store all the huge amount of data. So disks are 15 to 25 times cheaper per bit than a flash memory, and 300 to 500 times cheaper than a primary memory. So this is the technology that is used with server and warehouse scale storage, where we need to store more amount of data. Okay, so you can imagine for secondary permanent storage we can use magnetic disk technology. Then another point to be discussed is network technology. Another trend in technology is related to the network technology. It is based on the devices used for network transmission like the switches and the transmission media, where we use various chips, where the network performance actually depending on the capability of the switches as well as the medium used for that particular communication. So network switches also means not like 10 years back we are having better switches available, better transmission medias available, so that the network speed has also been increased slightly year by year. So these are the various trends that happens with the hardware technology side, where we need the computer designer or the architect need to have some consideration, and that is to be updated. That is to be updated in the sense that the capacity or the performance must be increased year by year. Now, two major points to be considered in relation with these devices, that is performance. Two performance measures, they are bandwidth and latency. So these two trends to be considered. So for all these previously mentioned devices, two things to be considered are bandwidth and latency. What is bandwidth? So performance will be evaluated based on this bandwidth and latency. Bandwidth, which is also called as throughput, which is the number of works done in a given time. How many number of works can be completed within a given time. So whether I can finish 100 different tasks within 1 minute, or whether I can finish 1000 tasks within 1 minute, etc. That is actually bandwidth. So more work to be done within a given limited time, we can say that it is having better bandwidth, or it is having a better throughput. But second point to be considered is latency, or which is also called as response time, which actually deals with, it is also a performance measure which deals with a particular task or for a particular event, whether if I am submitting an operation or an event, whether that event is being completed within a given time. So what is the response time for completion of that particular event? So these two aspects to be considered, but from among these two, more importance is given to bandwidth. Every time the technology improvement, we can see that the bandwidth was actually being outpaced the latency. Latency is important, but every time we are considering about doing more thing within the given limited time. So we can see that the bandwidth has outpaced latency across these technologies. We can look into a graph where we can clearly see this bandwidth and performance, means response time, latency comparison. In the x-axis you can see the latency improvement. So 1, 10, 100, all these are that much times, 10 times, 100 times, in that way it is given. In the y-axis they have given the bandwidth improvement 10 times, 100 times, 1000 times, 10,000 times. That is the improvement in bandwidth improvement, and x-axis deals with the latency improvement. So when we take different technologies, like for example I'll take the network technology. You can see starting from here, you can see network. This is the network line. So this is the place where when the latency of network was around 8 times improvement, in the same time the bandwidth latency was around 10 times. Okay. So when it was around 8 times, it is almost around 10 times. Now later, after some time, network became 10 times improvement on latency. 10 times improvement on latency. We can see that there was 100 times improvement in performance, means bandwidth. Okay, now network, this side you can see network, the latency is not at all given any importance here. Now look at some around 12 times improvement in the latency. In the meantime, it was having 1000 times improvement in bandwidth. Okay, so in the network side, always more importance is given to the bandwidth than the latency. Latency is important, but it is the major measure that is to be considered for that particular situation. Now when we take disk also, which is also the same thing, disk, you can see it was around 5 times here it is around 9 times. When it was around 6 times, here it is around 11 times or 12 times, or because it is huge, 10 to 100, that is different, right? So similarly, when it was around 8, it was around 50 times. When it was around 10, it was around more than 100 times. The bandwidth was improved. Similarly for memory also. Memory, when memory was initially the latency was given importance for a memory. When it was 2 times means, here also it is bandwidth only. So when it was around 2 times, means when it was around 2 times improvement, here it was around 4 to 5 times improvement. Now similarly, when it was around 4 times, it is around 11-12 times. Then similarly it goes upwards. Here also you can see maximum up to here only, some around 7 times, but here you can see more than 100 times. For microprocessor also you can see the same improvement. Latency maximum up to maximum up to 50. Okay, take 50, but here you can see more than 1000, means around 5000 times improvement was there in the bandwidth. So that is the history. The history says every time when we develop a system by various improvements in our various trends in technology, we were focusing on 2 performances. One is bandwidth and second one is latency, but almost all the times for all the devices, the bandwidth was given more importance than the latency. I hope this graph is clear. Now we look at the scaling of transistor performance and wires. So we know transistors are the components present within an IC. Similarly, we have got some wires also. So sometimes wires can be replaced with transistor, or transistors can be replaced with wires, or we can have transistors along with wires also. That is a structure that is present within the processor chip. So IC processors are characterized by the feature size. So IC is actually characterized based on the feature size. Feature size indicates the size of, as you know, when we look at an IC, how it looks like, that size. Normally we can imagine IC is always smaller in size. In your PC you can see very smaller ICs as well as some larger ICs like processor. So which is the minimum size of a transistor or a wire in either X or Y direction. So the feature size will be decided based on the size of transistor or the wire present in the in both direction of the integrated circuit device. So the transistor count per square millimeter of silicon is determined by the surface area of a transistor. So depends on the size of transistor. If the surface area of transistor is less, more transistors can be placed within the IC device. If the surface area of transistor is more, we cannot place that much. So what is happening actually, we are actually increasing the number of transistors within the IC every year. So automatically what is happening is the surface area of transistor is actually being decreased. So we are having very smaller transistors being created, and when we are placing these transistors into the IC, automatically the feature size, means the size of the IC will also be decreased with more number of transistors. Now the density of transistors increases quadratically with a linear decrease in feature size. So that is what I was mentioning. If the feature size decreases, the density, the number of transistors will be always being increases every time there is a decrease in feature size. So the transistor performance improves linearly with decreasing feature size. So automatically, if we are having more transistors, its performance also improves according to the decrease in feature size also. So these are the IC technology points to be considered. That is the reason why we are having a better IC and better performance system with a smaller size are being created for all the newer versions of computer system, laptop system, or any mobile devices that is currently available. Now, when we compare this transistor and wire, what is the major challenge to be considered? The major challenge is the transistor count should improve quadratically. So as per the previous theory, so we should always consider improving the number of transistors with a linear improvement in transistor performance. So whenever we improve the transistor performance, we should have the provision for decreasing the size of transistor, as well as we should have more transistors that is to be added into the integrated circuits. So transistor performance will be improved. So we should add more transistor. For adding more transistor, the size of transistor must also be reduced, and we should increase, or we should double the number of transistors present in a particular integrated circuit devices. This is a major challenge to be faced by all the computer designer or architect who is trying to design a new computer system. Now we are having a comparison with wires, just for comparison between transistor and wires. So what is the difference with the wires? So as the feature size of a wire shrinks, if the wire size shrinks, the wires get shorter, it will become shorter. But the problem is its resistance and capacitance per unit length get worse if the size of wires being reduced. That is a problem. So we are having a comparison between transistor and wires. So when we use wires, and if the size of wires being reduced, it is okay, the size will be reduced, but the problem is the resistance and capacitance which is actually required for this transmission will become worse. That means we require some resistance, we require some capacitance, but if the size reduces, it will affect the entire performance. So we are having these two properties to be maintained, that is resistance and capacitance. They are actually depending on 4 points. It is depending on the detailed aspects of the process. So what process we are working on, then what is the geometry of a wire, what is the width of that wire, the structure of that wire, then how much load is there on that particular wire, and also what is the adjacent element present with that particular wire. So it is depending on all these factors we will decide the how much resistance and capacitance is required for that particular wire. So if the size is being reduced, it may affect all these things. So it is always better to use a transistor in the place of wires for creating the integrated circuit, and by reducing the size of transistor, it will not affect that much on the resistance and capacitance of the integrated means the transistor that is present in the IC system. So these are the basic things that is to be considered when we discuss about the various trends in technology. The major trend is related to the integrated circuit design, and we have seen the features that are required for improving the performance, the measures that is to be considered, and the comparison between the wires and ICs that are used for the creation of a integrated circuit. So that's it for now. In the next session we will see the various power and energy aspect, how this power and energy, that also is a major element major requirement for the proper functioning of the internal devices connected to the computer system. So thanks for watching and goodbye.